Okay, everybody, so a little recap of what we did today. So we jumped all the way to the next module and the next topic. So connecting the dots is what it talks about. What we're mostly going to do today is talk about how an arithmetic sequence is the same thing as graphing a line in slope-intercept form. So we went through and we looked at the sequence. It says write the first 5 terms. So I plugged 1 in for n, so a of 1. I plugged in for n, and I got 10. Then I plugged 2 in for n, and I got 7. I plugged 3 in for n, and I got 4. I plugged 4 in for n, and I got 1. I plugged 5 in for n, and I got negative 2, okay? All right, so that looks like a pattern. Looks like we're going down by 3, down by 3, down by 3, down by 3, which is what we're going to talk about is basically the slope. So here's a function, and we could also write that as y equals a negative 3x plus 10, because y and fx is the same thing for us. And we plugged in 1 for x, and I got 7. And I plugged in 2 for x, and I got 4. I plugged in 3 for x, and I got 1. I plugged in 4 for x, and I got negative 2. And I plugged in 5 for x, and I got negative 5. So we notice this is pretty much the same numbers. We want to show that an arithmetic sequence can also be written in the form of a line. Okay, so then we turn the page. We looked at these two sequences, where the first one, we've got 3, 6, 12, 24, 48. Turns out to be a geometric sequence. So we graphed that one, and it curves. And then the sequence 3, 6, 9, 12, 15 is a straight line. And we recognize that that one's got to be arithmetic. So we know that this one, sequence A, has to be geometric. And then sequence B must be arithmetic. And you can even draw a straight line if you wanted to. Now what makes them the same? They're both discrete because you don't connect the dots. They both have a first term. They're both increasing. And they both start out at 3. That's what they have in common. But then from there, they're different. Geometric, arithmetic. So then we took a look at these 4 graphs. And we matched it up. Graph A, we thought went with equation number 3, this one here. We matched up graph B to this one here. We knew it was going negative, so we knew it had a negative here. We graphed up C. We paired up with this one here, and then D, we paired up with this equation here. And we thought, well, we could simplify it and show that it has the equation of alignment. So then, still trying to make the connection between a line and a sequence. So we turn the page and we say, okay, what do we know about all these? Well, they're all straight, they're all linear. So we could use y equals mx plus b. So okay, let's take a look at graph C. So we looked at graph C, we drew in the line, okay? And then we were able to look at slope up 4 over 1. Up 4 over 1, it would start at negative 2. And as a sequence, we saw up 4, up 4, up 4, up 4. And what we realized is that the common difference and the slope are going to be the same thing. So we said, wait a minute, the common difference and the slope are the same thing. If it's arithmetic, it has to be arithmetic, okay? So then we came up with the equation, and we simplified how these two can be the same. So I took my sequence, and I rewrote it. It's my sequence from over here. I took it, and I rewrote it, and then I simplified it. 4 times n, 4 times negative 1. I put my two integers together, and I got a 4n minus 2. So sure enough, if I have a linear equation in the form of y equals mx plus b, it can also be the same as a sequence, an arithmetic sequence. And that's what we talked about. So the homework we talked about today had to do with pages 192 and 193. So that's all I have, and we'll talk a little bit more tomorrow. Okay, so have a great day or weekend.